in order to add and subtract these rational expressions. Now, again, you have to remember basically that a rational expression, all it really is a fraction. In order to add together two fractions, they have to have a common denominator. If they do have a common denominator, you just bring it through as the denominator of your answer. And then simply on top, or in the numerator of the fractions, you just perform the operation that's given to you. If it's addition, you add them together. If it's subtraction, you subtract naturally. So 2 plus 5 would be 7, and you get 7/11ths. So the first step is to add together expression. Now, obviously you add it if it's adding, you subtract it if it's subtraction. That should be obvious. And the only thing you have to remember is you have to have a common denominator first. Once you do that, step 2 is try and simplify. Now, if I look at 7 and 11, the factors of 7 are only 7 and 1. And of 11, they're only 11 and 1. The only thing they have in common to simplify with would be the number 1, and 7/11ths reduces to, well, 7/11ths, which means it was irreducible, so it was already in lowest terms. So you add the pieces together first, keep your common denominator, and then you try and simplify. So now I get to the second question here. What you're seeing here is now that the 3 and the 7 are not common to each other. So I can't just put 21 here, I can't put 10 there, I can't put 7 there, I can't put 3 there. They have to be identical. Now, a quick way you can do this is you can take these two things and multiply them together and get 6. Multiply those together, you get 14. 14 plus 6 is 20. Multiply those two things together to get your denominator that's common. Now, 21 is common to both 3 and 7. And why is that? Well, if I took 3 times 7 and 7 times 3, what would I get? I would get 21. If I'm multiplying this bottom fraction by 3, in order to get a factor of 1, 3 over 3 is 1. A factor of 1, I had to use a 3 here to get that. 3 times 2 is 6. Over here, you get 21 on the bottom, so it was common to this 21. I had to multiply by 7. But a factor of 1, which uses sevenths, is 7 over 7. 7 times 2 is 14, and I got that. Now 20 is 4 times 5, or 10 times 2, or 20 times 1. 21 is basically 7 times 3, or 21 times 1. The only matching factor they have is 1. So could I reduce this thing? No. And the answer would be 20 over 21. We can move on to the next one. 5 times 4 is 20. 1 times 10 is 10. 4 times 10 is 40. 10 plus 20 is 30. So when you add those two fractions together, 1/4 plus 5/10 is 30 over 40. If you break these down into factors, is there a greatest common factor amongst 30 and 40? Well, it's going to be 10 times 3 and 10 times 4. They do have common factors other than 1. In this case, 10. So when I go to simplify 30 over 40, the common factor 10 over 10 comes out. And again, 10 over 10 is worth 1, so it just crosses out. And my simplified version for my answer is 3/4. 1/4 plus 5/10 is worth 3/4. If I start mixing in some letters into it, it's not really that much different. 5 times x is 5x. 15 times 3x is 45x. 15 times 5 is 75. 45 plus 5 is 50x. What are the factors of 50 and 75? Well, here's the thing. The greatest common factor of both of them is 25. Times 2 and times 3 respectively. Don't forget on top you still have a factor of x. The 25's cancel out as a factor of 1. And you're left with 2x over 3 for your reduced answer. Now, when I start to get polynomials in the bottom, meaning there's x squared and there's minus 9, there's two pieces, polynomial, more than one. Again, if they're the same as each other, just like if they both had 11 in the bottom, you just brought it on through. So we're going to do that here by that same rationale. X squared minus 9 and x squared minus 9 leaves a denominator of x squared minus 9, which is great. On top, x plus 3 is just x plus 3. But we have to try and simplify. So when I go to do that, x plus 3 is as simple as it gets because it's x to the first power plus 3. But this has x to the power of 2, which means it can be factored. X squared is x and x. The minus sign goes in the first bracket. Because the last sign is also the same thing, is a negative sign, means go the opposite of this first sign, opposite of minus is plus, and factors of 9 that have no difference are 3 and 3. So now the bottom will refactor into x minus 3 and x plus 3, and the x plus 3 factors match up. So they cancel out as a factor of 1. There's nothing left on top, so you hold it with a place value of 1. On the bottom you have x minus 3. So this fraction reduces to 1 over x minus 3, as long as x is now in the bottom, which means I could have an undefined point, where x can't be positive 3 here, and it can't be negative 3 there. And that's how you add and subtract rational expressions.